For 16 million years, the Earth was a vast, unbroken greenhouse. The late Cretaceous period provided a stable, hyper-oxygenated climate, where a single group of animals successfully occupied nearly every available ecological niche on land. The specialized efficiency of that era is preserved in structures like this complete Tyrannosaurus rex skeleton. Animals of this scale required massive caloric intake, supported by an ecosystem stable enough to maintain their high-energy metabolic demands. 66 million years ago, a piece of rock entered the upper atmosphere, traveling at 40,000 miles per hour. The object was roughly 6 miles wide. If placed on the surface today, its peak would reach the cruising altitude of commercial jets, matching the total volume and mass of Mount Everest. At that speed, it took less than 3 seconds to cross the atmosphere before striking the shallow ocean, covering what is now the Yucatan Peninsula. Earth is nearly 24,000 miles in circumference. The crater left behind by the impact measures just 90 miles across. A local impact site creates a spatial anomaly. A kinetic blast in modern-day Mexico does not inherently explain the death of herbivores, like this Triceratops, grazing thousands of miles away on the opposite side of the planet. The strike functioned as the first link in a chain of 4 cascading planetary systems failures. The first mechanism of extinction was the immediate kinetic blast. The friction of the strike instantly vaporized the 6-mile asteroid and the bedrock beneath it, creating a fireball that outshone the sun. The energy release shattered the local continental crust. Earthquakes radiating from the Yucatan triggered mega tsunamis hundreds of feet tall, stripping the coastlines of North and South America down to bare rock. Physical destruction of this type dissipates all distance. Life beyond the immediate continental radius survived this initial shockwave. This cross-section models the second mechanism of extinction. The impact ejected millions of tons of vaporized crust upward, pushing it past the atmosphere and out into the vacuum of space. Out there, the material rapidly cooled into tiny glass beads. Gravity pulled the debris back. The friction of countless glass beads undergoing atmospheric re-entry simultaneously generated extreme thermal radiation. The upper atmosphere heated to the temperature of an industrial oven. The sky itself became a thermal radiator. Below, the intense radiating heat caused the spontaneous ignition of dry flora, sparking massive wildfires that burned through the world's forests. The shockwave pulverized the Americas, while the falling ejecta trapped the entire planet beneath a dome of lethal heat radiating from the sky. The global fires generated vast plumes of ash, initiating the third mechanism, the impact winter. The severity of this phase was dictated by the specific geology of the Yucatan target zone. The bedrock the asteroid struck was formed of anhydrite and gypsum, minerals rich in sulfur. The blast drove millions of tons of vaporized sulfur gas directly into the stratosphere. This map illustrates how the combination of ash and atmospheric sulfur created a dense aerosol shield. This layer acted as a mirror, completely blocking incoming solar radiation. Global temperatures plummeted, and the Earth fell into darkness for months. Without sunlight, the process of photosynthesis halted immediately. This schematic maps the resulting trophic collapse. As the foundation of global plant life died off, the biological chain reaction began. Herbivorous dinosaurs required hundreds of pounds of vegetation daily to maintain their bulk mass. As the forest rotted, they exhausted their caloric reserves and starved. With the herbivores gone, the apex predators lost their only fuel source. The ecosystem dismantled itself from the bottom up. The dinosaurs' immense metabolic requirements guaranteed their starvation in a world where the primary source of global energy, the sun, had been blocked. Embedded in this sedimentary rock is the physical record of the resulting collapse. The 4-step chain of kinetic shock, atmospheric heating, winter, and starvation eradicated 75% of all plant and animal life, ending the lineage of the non-avian dinosaurs. The disaster functioned as a severe biological filter. Survival was dictated by highly specific physiological traits. To endure the thermal radiation and the subsequent freezing temperatures, an organism required the ability to burrow underground. To survive the trophic collapse, it needed a diet based on low-calorie scavenging. Early mammals and the avian dinosaurs, the ancestors of modern birds, possessed these characteristics. Their small size allowed them to seek shelter in the soil and subsist on the dead insects and seeds scattered in the ash. The eradication of the dominant reptiles emptied the world's ecosystems. As the atmosphere cleared, it created a massive biological vacancy for the surviving species. The removal of the giant reptiles opened the world's ecological niches, creating the structural vacancy required for mammal diversification and the rise of the primate lineage.